Hey guys, I just wanted to go through a couple of the homework problems just in case you were having any difficulty. Just a couple of quick reminders for you guys. Make sure you get all 3 sets of homeworks done before I come back next time. The more practice you're going to do with this, the better off you're going to be, I promise you. All right, so take your time with the homework. Make sure that you're submitting it. Again, take a picture of the homework. Make sure you submit it on Canvas. It's all listed there online, all right? Let's look at a couple of practice problems here. Aluminum oxide, Al2O3, a buffing powder, is to be made by combining 5 grams of aluminum with oxygen. How much oxygen is needed in grams to react with the aluminum? Again, just same stuff as before. We are making aluminum oxide by combining aluminum with oxygen. So aluminum plus oxygen. Don't forget Brinkelhoff. Making aluminum oxide. Sorry, it tells you what it is, Al2O3. Sorry about the subscripts, I forgot about that part. Balance your equation. Okay, let's look back up here. What is given? What do we want? 5 grams of aluminum is given, and we want how much oxygen is needed in grams. Again, read it carefully. It says to react the aluminum, so don't get confused there. Make sure you know specifically what is the question starting with and what are we asking for at the end. Start with what you know. 5 grams of aluminum. Take it one step at a time. Grams of aluminum on the bottom. What do we convert that to? The only thing we convert it to is moles, so let's do that. Definitely have to make this smaller. Okay, it's going to get a little bit teenier now. Moles of aluminum on the bottom. Again, the only time I can go from reactant to product, or what I start with what I want to go to, is through moles. So I use the mole ratio to get there. And the question's asking for oxygen. Again, use those coefficients. 4 for Al, you can see it in the balanced chemical equation. 3 for oxygen. Go another step. Mole of oxygen to gram of oxygen. Don't forget oxygen's a diatom. Also keep in mind, again, anytime you go gram to mole, mole is always 1, right? The only time you'll ever have any number other than 1 with moles is if you are dealing with the mole ratio, which is right there. All right? Your equation set up, plug in and solve. Let's see what we get. So I'm going to start with 5 times 3 times 32 divided by 26.98 times 4. Again, significant figures, I need 3, so we're going to go with 4.45 grams of oxygen. Okay, that's all there is to it. Plug in and solve, just like any other problem that we've done so far. Under the right conditions, ammonia can be converted to nitric oxide by the following reaction. How many grams of oxygen are needed to react with 56.8 grams of ammonia by this reaction? So, nice chemical equations already given to us. So, all we need to do is look at what we know, what we don't know, and convert. So again, how many grams of oxygen are needed to react with 56.8? Well, I've given a number there, so that's going to underline that. Circle what we don't know. How many grams of oxygen? Same rules, same stuff as before. Start with what you know, 56.8 grams of ammonia. In case you don't know, ammonia is NH3. Pretty important compound, talking about industrial or pharmaceutical chemistry. Grams of NH3 on the bottom here. And the only thing I can convert that to is moles. NH3, plug it in, should be 17.04. Again, find that on the periodic table. Let's keep going. What do we want? We want oxygen. I'm going to go moles of NH3 to moles of oxygen. Again, the only way you can convert between different chemicals is by using the mole ratio, given by the balanced chemical equation. 5 for O2, NH3 gets a 4. Take it again. Again, we're going to do 1 mole of O2. Plug it in. Oh, no. Plug it in and solve. Doing the math on my calculator. Again, significant figures. So we need 3, and we round. So we get 133 grams of oxygen. Boom, you're done. So again, follow it step by step, just like we talked about. Start with what you know. Grams, you can convert it to moles. Moles of what you have to moles of what you want. And moles back into grams. Let's do one homework problem from number 28. Let's go. 75 grams of potassium hydroxide are permitted to react with 50 grams of hydrochloric acid. How much potassium chloride is formed? So we need an equation for this. So potassium hydroxide is reacting with HCl. Potassium hydroxide plus 1 minus 1 reacts with HCl. So, again, you have to figure out what type of reaction is this. And you look here, you should recognize that it's a double displacement reaction. So whatever's negative will switch. So K is no longer going to be with OH. K is going to be with Cl. And H is going to be with OH. You can write it like that. You can write it as water. I do not care. However you want to do it is fine. You go through, balance it, not require much work there because it's already balanced. Everything is peachy as it is. So let's look at what our question is. 75 grams of potassium hydroxide, well, that's a given. And 50 grams of hydrochloric acid, that's a given. The question is asking for potassium chloride. Let's solve. Start with what you know. Again, guys, I can only do this so much, but the process is exactly the same. You go through it over and over again. Starts kind of making sense. Molar mass there found on the periodic table. Okay. Again, what do I want? Potassium chloride. So, mole ratio, 1 to 1. That's easy enough. Let's get it to grams, guys, and then we'll do some math. Again, mole's always 1 when you go mole to gram. KCl. 74.55 found on the periodic table. Okay. Plug it and solve. $99.6 grams of KCl. Are we done? No, we gotta do the second part, right? Start with 50 grams of hydrochloric acid. Again, follow the same steps as you do before. Find molar mass in the periodic table. Remember, it's always 1 mole. Whoa! We're not done yet. Let's go to another step. Mole of HCl. What do I want? Moles of KCl. Again, 1-to-1, balanced chemical equation ratio, right? Again, 1 here. Do the math and solve, guys. $102. So, 2 answers here. Which one is correct? It's the one that's the lowest. So that is the right answer. So 99.6 is your answer. If I ask for limiting reactant, KOH is limiting. HCl is in excess. That's how you do it. 1 step at a time, guys, all right? I can't really stress how much more you need to do this. You should know the steps by now. Grams to moles, mole to mole back into gram. Take your time with it. Ask questions. Help each other out. We'll see you on Monday, guys. Take care.